if you have an image like this one, and I wanted to create code that could tell me who are the people in this image. Can you tell me where in this image people are, or where are the kites in this image? You could traditionally write a set of procedures or guidance to say a person looks like an object with two appendages at the bottom with arms, legs. Typically, they may be wearing clothes that have a specific color and detect that through the pixels in the image. But pretty quickly, I would run out of time to create the set of rules that would correctly identify a person in any image. It would be almost impossible. And same with kites, same with any other objects. So machine learning, and TensorFlow specifically, at a broad level, it lets me create an algorithm that essentially looks at an image and takes a guess at identifying or classifying the objects in that image. And that first guess is going to be incorrect. But if I already know what the correct answer is, if I've already classified these manually, then I can train this algorithm to improve. And over time, because in computation you can do this millions of times, you can train an algorithm to gradually increase its chances to detect. Essentially calibrate the weights in the algorithm so that it can detect the people correctly given known data. It can approach your answer over time. And TensorFlow is a fascinating module in Python that lets you do that essentially. So I've created some demos here that leverage TensorFlow and eventually connect to a GIS to do some work with GIS. So the first example here, I think, yeah, I've already executed it here. I'm not going to go into the details, but again, I'll post this notebook up on GitHub and anyone is able to take a look at it. I'm working with a model, a TensorFlow model that someone has already created. Essentially, they've already trained an algorithm to find objects. And I already have a data set called COCO. And COCO stands for Common Objects in Context. So it's a set of images that have already been essentially classified for a series of objects. And they're a good training data set if you're working with algorithms. So in this case, I'm able to pass to this trained model. I've simply downloaded the model and executed it against images. And yeah, at this point I can execute the detection here. So we're going to take a look at this image and see how it classifies it. And because it's already connected to a model that has been trained on COCO, it's able to essentially determine that the kites with a specific set of precision are found in these locations and that the people are detected here. So images are interesting, but I was interested in, especially during the hurricane, looking at a stream of images or a video feed. And using the same notebook, I was able to change a couple of components there. Python, again, has another module called CV2. And CV2 lets you interface with video capture. So I'm going to go ahead and execute all of this. And sorry, spoilers. My webcam actually just came on, and very shortly a Python window is going to pop up with a live video feed. But essentially what I've done is instead of reading from my images folder, and I'm going to go to the cell that determines that. Yeah, if we go back to the previous notebook, I had a cell here pointing to a directory with my test images, and I would pass that image to the model to perform detection. I've essentially taken that part out. I've instantiated my video capture as a variable and passed the NumPy arrays, which is another Python module, to that classification cell. And now I think I have my video feed. And there I am. So it's able to detect me because it actually has a refresh rate that can be, I think it's like 10 frames per second, so it's pretty fast at performing the algorithm. But it can detect a series of objects, so if I pass a cell phone, it's able to identify that as either a cell phone or a remote. If I pass a bottle, I think it should detect that, depending on the bottle. I thought it was a cell phone briefly. It's not able to do that. Fire hydrant. There it is, bottle. So it's not the best model, but you could see specifically classify or training your own model for a use case and making sure that it's very accurate. And what I thought about doing is taking this concept and connecting it to a layer in a portal. So I'm going to quit out of this, close and halt this. Yep, I'll leave this, and then I have one final demo here, where, again, I'm doing the same workflow, but I've appended some cells with additional logic to leverage the API, connect to my API, and right over here, I have some logic to update a point layer on a map. So let's go ahead and execute this. And again, my webcam is about to come on. Because we're authenticating with S3 Federal, it's going to do the Okta thing, so I'll have to pass it the token shortly. But the idea is once this starts executing, this map starts with a point here that is currently classified as false. And I apologize, this is a little difficult to see. But the idea is once it starts detecting people in the video feed, then it'll send a request to that layer and perform an update on that point and change it to true while I'm on the video cam. And then if I go away from it, it should go back to false. So let's see that in action. Go back here, insert that so that we can authenticate. And at this point, let me put my map on half of this. And there is my image. And very shortly, there it goes, it changed to true. And the proof of concept is if we go away from the web stream, does it go back to false? So let me hide from the camera for a second. And then let me update the map, and there it goes to false. And there it is. So actually, let's go back and see if we can update to true. It may take a second. Yeah, there it goes. I ran out of time, but I wanted to do this with, you could see many use cases for this. I wanted to do this with a web stream of a palm tree, for instance, during the hurricane, and have that fall, if possible, on a demo, and be able to detect points and attribute them in a specific way without having people monitor these web streams. And funny story, hopefully. I tested this last night at home with my dog. And my wife always calls our dog her teddy bear. And no kidding, this is my dog. This thing classified it as a teddy bear.
55%.
With 55% accuracy. So there's proof through machine learning that our dog is her teddy bear.